Greetings and welcome to the Plsql Channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on writing dynamic SQL in Oracle Plsql, and the topic is Oracle11g Enhancements, of which there are many interesting ones to know about. Some quick reminders. Download code and supporting documents from Plsql Obsession, my portal of resources for Plsql developers, at toadworld.com/sf. Here's Plsql Obsession, lots of resources to access. In terms of this training, download the demo.zip file that contains all the scripts that I'll be running in the training, and training seminars and presentations provides additional details and supporting documents, PowerPoints for the trainings. In addition, you should be comfortable with both native dynamic SQL, the execute immediate statement, and the DBMS SQL package before proceeding with this lesson. DBMS SQL is covered primarily in the Method 4 dynamic SQL lesson, and execute immediate is discussed in all the other dynamic SQL lessons in this series. So the enhancements in Oracle 11g. First of all, you can now parse and execute very large strings. In other words, you can pass a clob to execute immediate and to DBMS SQL parse. There's improved interoperability between the different methods of doing dynamic SQL. Essentially, you can convert between a DBMS SQL cursor, or pointer to a cursor, and a cursor variable. And as well, you can go back the other way. So essentially from DBMS SQL to native dynamic SQL, NDS to DBMS SQL. And improved security. Now DBMS SQL cursors are randomly generated, and Oracle has put in place the ability to deny access to and use of DBMS SQL with an invalid cursor or a change of effective user. Obviously, we'll go into detail on all these topics. Parsing very large SQL statements. In the past, execute immediate was limited to a single var_char2 string, and DBMS SQL parse also to a string, or you had to pass an array of variables, an array of strings. Now execute immediate and open_for accept a clob. Now for most of you, I imagine that worrying about whether or not your string is larger than 32,767 characters was not a big deal. But if you're generating SQL statements, or if you have a very large table, let's say with 1,000 columns, you could actually hit that limit without a whole lot of trouble. And in the past, the workaround for hitting that limit, let's just pull up my reference to my files here. In the past, the workaround for hitting this limit of 32,767 was switching to DBMS SQL parse. Let's take a look at the exec DDL from file script. So prior to 11g, if I wanted to parse an arbitrarily large string, for example, I wanted to read the contents of a file and then execute it as a DDL statement, which is what this program does, I'll read all the data from my file, I'll load it into my array, and then, prior to 11g, what I would have to do is use DBMS SQL.parse and pass it not a string, but an array of strings. And then Oracle would glom the strings together, concatenate them together, and then execute that statement. So this was the approach you would take to get around the limitation of a 32K string. Unfortunately, using DBMS SQL in this way is fairly complicated and verbose. You have to populate the collection, you have to determine the start and end points in the collection. It's a very flexible, powerful feature, but gosh, it'd be nice if we didn't have to use it. And now, we don't have to. So you can either pass a clob to DBMS SQL.parse, you don't have to use the collection binding, or you can simply pass a clob to execute immediate. So let's take a look at the 11g version of this program. Of course, I still need to read the contents of my file, so all that code is the same. But now I simply say execute immediate DDL. So in other words, when I read my file, I simply construct my string myself. And it could be arbitrarily large, it's a clob. And then I simply say execute it. So that is a heck of a lot easier than writing all of this code, populating the collection, and so on. A small enhancement, but a very valuable one. Let's move on. Interoperability. So prior to 11g, you basically had two choices, and you still do. in your mechanisms for implementing dynamic SQL, execute immediate or native dynamic SQL, and DBMS SQL. And DBMS SQL is by far the more complicated and more difficult to deal with and also slower. But it could do things that you couldn't do with native dynamic SQL. In particular, Method 4 dynamic SQL. If you're not familiar with Method 4, then you should stop watching this lesson right now and watch my separate lesson on Method 4 dynamic SQL, what it is, and how to use DBMS SQL to implement it. The problem is that, as I said before, DBMS SQL is a big, complicated package to use, to learn, to execute. And native dynamic SQL, execute immediate, and cursor variables are much easier to work with. So what Oracle has done with 11g is give you the ability to start with one. I can start with DBMS SQL, and then I could switch to cursor variables by converting my cursor handle to a cursor variable or a ref cursor type. And if I started with native dynamic SQL, I could switch to DBMS SQL by converting that cursor variable to a cursor handle. Now, the first, converting to a cursor variable, is useful when you need DBMS SQL to bind and execute, but easier to fetch through cursor variables. So the bottom line is that you don't know how many variables you have to bind into your statement, so you need to use DBMS SQL to do that. But once you've bound in your variables, fetching the data back is very straightforward. There are a fixed number of elements, and you should be able to do it with a static cursor, static set of data. So you can switch to cursor variable. The DBMS SQL to cursor is valuable when binding is static. I know I'm just binding in 1 or 0 or 15 variables, but my select list is dynamic. I don't know how many things I'm selecting. Let's take a look at each one. So, toRefCursor converts a SQL cursor number, a handle passed back from DBMS SQL.openCursor, converts it to a weak cursor variable. And you can then use that with native dynamic SQL or even static statements. Before passing a SQL cursor number to refcursor, you have to open, parse, and execute it. In other words, it has to be ready to go. And you've done that through your DBMS SQL statements. And after you convert a cursor number back to a refcursor variable, DBMS SQL operations will no longer be able to work with it. You can only work with it as the refcursor variable, not as the cursor handle. Let's check it out. So let's see, in this example, I've got a situation where my binding is variable. I don't know how many things I'm going to be binding in. Here, for example, is my parse statement. I've opened my cursor, but I don't know how many things I'm binding into my where clause. My where clause is variable, highly variable. So, in this case, what I will do is pass into my local subprogram employee names, I'm going to pass my where clause, my list of bind variables, and the list of placeholders that those bind variables are associated with. And then in my code, I will say for each of my placeholders, bind that variable. So pass it the cursor that I just allocated, pass it the name of the placeholder, pass it the value of the bind variable. And this is clearly assuming that all my bind variables are strings. If you have bind variables of different types, this can get much more complicated. But for a simple example, it'll serve its purposes. So I've bound in my variables. I could have 2, 25, 1,000. Then I will execute my statement. Now here's the thing. That part I need DBMS SQL for because I needed to bind multiple variables. But check out the select list. It's just the last name. Now, if I use DBMS SQL to fetch the data back as well, my code is extremely complicated. In fact, let's take a look. I'll take a look at the intab program that's covered in detail in my Method 4 dynamic SQL lesson. And in this case, what I would have to do is define each of my columns by calling define column of the appropriate type. And then after I fetch my data, I have to fetch a row. And then for each of my columns, I would have to specify the column value program to retrieve the value from that cursor at the specific index. Very complicated, very verbose. It'd be really nice to avoid writing that. And that's the situation we've got now in 11g, because after I execute, I can say, hey, I'm just selecting a single name. I know that. So I'm going to call toRefCursor, convert my dynamic cursor to a cursor variable. And then notice my function will return that cursor variable. So all the details of using DBMS SQL to bind, to execute, open, hidden away inside this program, and it simply passes back a pointer to the data. And then I can say fetch all the names. I can even say fetch bulk collect into my collection of names, iterate through the names, display them, or do whatever I need to do. But notice, no more DBMS SQL. Because it's a fixed number of elements in the select list, I don't need the flexibility of DBMS SQL. And when I run this program, I see all the names of the employees in department. Let's pull it back up. In department, where is it? 50. So I look for all the employees where department ID, that's the placeholder name, is equal to 50. So this is the classic scenario in which you'll want to take advantage of the 2ref cursor program. I know how many things I'm selecting. I don't know how many things I'm binding. So the bind process, the first phase of the process, to get to the point of executing, is done with DBMS SQL. Then I hand off the cursor to my cursor variable, and then I can use my static standard operations to iterate through my cursor variable. Let's take a look at the reverse direction, to cursor. In this case, I'm going to take a cursor variable, and it could be strong or weak, and I'll convert it to a SQL cursor number, a DBMS SQL cursor handle, and that can then be used in calls to DBMS SQL. Note that before you pass the ref cursor variable to the to cursor function, you have to open it. It has to be a valid ref cursor. And after you convert a ref cursor variable to the SQL cursor number, you can only use it with DBMS SQL. You can't use it with native dynamic SQL operations. So once you make the conversion, you've got to stick with the new approach. I suppose you could convert back and forth multiple times. That would be a really complex scenario. Let's take a look. 11g to cursor. So in this case, what I want to do is show data from the employees table for a given department ID. So I have a single bind variable, but I don't know how many columns I'm selecting. So this is another form of dynamic SQL method 4. So I construct my select statement, and notice in both of these scripts I've got a comment here about this kind of concatenation leaves you vulnerable to SQL injection. The comment was here as well. If you're not sure what SQL injection is, watch my best practices for dynamic SQL, in which I give you at least a basic introduction to SQL injection and talk about how to avoid it. So, fixed number of bind variables, but variable number of columns. That means I can't use execute immediate. I'm going to use DBMS SQL, but I'm going to start by opening up my cursor for this statement. So this is an example of using a cursor variable. I open my cursor for the specified statement. And at this point, all Oracle has to do is parse the statement. And it will do that and make sure that my column list is valid. So that gives me a valid statement, and it's opened. Now what I want to do is select the data from it. And I don't know how many things I'm selecting, so I need to switch over to DBMS SQL. So I call the to cursor number program, pass it over, pass it the cursor, retrieve the cursor ID, and then what I can do with DBMS SQL is take advantage of a fantastic program called Describe Columns. And that says, you've already got the cursor handle. Let me figure out how many columns you've got and what their data types are. So I call this program. It returns a table or collection of records about the columns. And then I can iterate through my different columns. I can define each column. And then I can fetch each row. And for each of my rows, I can go through each column and call column value to retrieve the value and then display it. Now again, this is a lot of work, correct? Compare this process to simply saying, well, get the cursor variable, fetch it into a collection of names or records, and then iterate through and access the values. So this is the static phase of retrieving values from a collection, from a select statement, and that's very simple. Doing it with DBMS SQL is way more complicated, but it's the only way to do it. So you have to accept the complexity and fall back on DBMS SQL when you don't know the number of columns you're selecting, but at least we can make this part of the process so much simpler than it would have been if we had to use DBMS SQL. And I'll run this code and display the data. So there are the column values, the column names, and the column values that I was displaying here. Improve security. So there were several features of DBMS SQL that were causing headaches for people who were very concerned about security. One of them is that when you call DBMS SQL.OpenCursor, which is what I'm doing, in this one, which is what I'm doing right here, Oracle returns an integer that points to the result set. And Oracle was generating sequential values, so OpenCursor returns 1, then 2, then 3, then 4, which made it easy for hackers to predict what cursors might be valid in your application and use it to hack into your code. So now Oracle will generate cursor handles that are now random, so they can't be predicted. In addition, if you pass an invalid cursor handle to many DBMS SQL programs, Oracle will disable DBMS SQL in your session. In other words, if somebody's hacking around and trying to just throw numbers at DBMS SQL.parse or .execute to see if it can use that cursor handle as a valid handle, Oracle, and it's not valid, Oracle will immediately say, you must be hacking, we're going to shut down DBMS SQL, and you have to reconnect your session to re-enable access to the package. And finally, and most complex, you can specify a security level for DBMS SQL cursor management. When you open the cursor, you can specify rules about how that cursor can be utilized. And this is to minimize, again, the danger of SQL injection. Let's take a look at each one of these. So random cursor handles. Let's close all these other files to make it easier to see. I'll simply call OpenCursor 3 times. Let's take a look at what we get. So, randomly assigned values. I can't vouch for the randomness of the formula, but they look pretty random to me. It's unlikely that anybody's going to be generating code that will spin through a million different numbers, trying every different number to see if they can find a valid one. And if they do anyway, they're going to have problems. Their access will be denied. So let's take a look at that. So in this program, I've got a procedure called setSalary, and I open my cursor, and then I parse the statement, the update statement, execute the update statement, and show the number of rows modified, and then close the cursor. So that's what setSalary does. So I'm going to do that. I'll run setSalary and update everybody's salary to the same thing. We'll see if it works. Then I'm going to try to execute using some invalid cursor handle. At least I think it'll be invalid. We'll see what error occurs. And then I'll try to set salary again. So I'll prove that the program works, and we'll see what happens after I try to touch an invalid cursor handle. So first of all, I'm able to set salary. Notice it modified all 107 rows. And then it tells me DBMS SQL access denied. And then I try to run it again, and I can't get at DBMS SQL. So, once this happens, once you pass in an invalid cursor ID, Oracle will not let you do anything with DBMS SQL until you reconnect. So if I close down the session, I reconnect, then I should be able to run the setSalary program again. So let's not do all the rest of this. Let's just run setSalary and make sure that it is now valid once again. Yep, I can run it. But as soon as somebody tries to hack in, or perhaps you pass it a bad variable, you will get an error, and then you will either notice that you're passing a bad variable to DBMS SQL.execute, in which case you found a bug, Oracle helped you find a bug, or you've got a problem with hackers. So in other words, what you really want to be doing is trapping these errors, logging them, and probably issuing an alert to whomever is responsible for security saying we've got a problem, somebody's trying to hack in. And finally, let's take a look at effective user ID. So Oracle found that one of the ways that people might try to hack in is grabbing somebody else's cursor handle and then utilizing it. And that will often happen with changes of the effective user ID, the user under which the actions are occurring, or roles may have changed. And these that Oracle has decided are all possible indications of hacking, of SQL injection. So if you want, you can specify a security level when you open your cursor. And the security level will restrict how these DBMS SQL programs can be used. So the default is to provide no value, which is the pre-11g approach, and that will be a cursor security level of 0. And then you can also specify 1 or 2. So what I've done here is create two programs. One is open parse the cursor. So I pass it a security level. It opens with that security level. And then it parses the statement, update employees, set everybody's last name to essentially the same thing. This is an authID current user program. That's an invoker rights program. And this means that when I run this program, it runs under the authority of the currently connected user, not the schema that owns the procedure. So that's an invoker rights program. Then I have execute cursor. That takes the cursor that was opened here, and it executes the statement. This is an authID definer program. That means that this program always runs under the privileges of the schema that created the program. So these are essentially running, or potentially could be running, under different effective user IDs. That's the terminology that Oracle uses. In my example script, what I'm going to do is run through a variety of scenarios. One is, first, I'm simply going to pass. I'm going to open a cursor and not pass it a security level. So this is the pre-11g approach. So this is, let's put that in there, pre-11g. Then I'm going to pass it a 0 value for security level to see if we can do that. Certainly the Oracle documentation indicates that I should be able to do it. Then I'll specify 1 for my security level. So it'll do an open cursor passing it a value of 1. And then what I'm going to do is open and parse my cursor, and that's under my invoker rights. And then I'll try to execute it as a definer rights program, and we'll see what happens. I run my code, and here's what I see. So I don't pass the security level, no problem, no errors. Try to set it to level 0, and oddly enough, Oracle tells me, no, you can't do that. Security level of 0 is not allowed. But if you look in the documentation, it clearly defines 3 levels that are valid, 0, 1, and 2. So what they really mean is, if you want a security level of 0, don't pass it anything. So you'll just pass a null value. That's rather strange and confusing, but that's the way it goes. And then finally, set level to 1 and call definer rights program. And then I get the -29470 error. Effective user ID or roles are not the same as when the cursor was parsed. So Oracle has detected a change. I went from authID current user to authID definer. And that can have all sorts of impacts in my program, even when I'm not running dynamic SQL. But in this case, since I specified a security level of 1, Oracle will reject my effort to use that cursor and raise this error. And then DBMS SQL will be invalid and unable to use it in my session. So if you're responsible for security, if you're doing a lot of dynamic SQL, with DBMS SQL especially, take a look at these features, try them out, make sure you know how to apply them when you want to use level 1 and level 2, and you'll find that your application will be much more robust, much less likely to be injected by an outside and malicious user. Conclusions. So both mechanisms for dynamic SQL have been improved. Actually, DBMS SQL probably has the biggest impact with all the security enhancements, now supporting the CLOBs, but mainly the ability to move between native dynamic SQL and DBMS SQL is really critical. And now if you do have to implement method for dynamic SQL requirements, it's so much easier than it was before. You can now say, well, I have to use DBMS SQL to select my multiple elements, and that's cumbersome and difficult, but at least I can do it. But I'm not binding anything. So I can at least, or I'm binding a fixed number of variables, so at least I can fall back on my cursor variables for that, and so on. And again, if you're required to use DBMS SQL, usually because of method 4, and if you are responsible for security, and these features are facing outwards, in other words, they can be used by external users, make sure to take full advantage of these new features. Next steps. If you haven't already done so, download that demo zip file. Try out these different scripts, especially, of course, if you're on Oracle 11g, and make sure you understand how these work and how you can apply them. And when you upgrade to 11g, you'd probably want to go back to your most complex dynamic SQL programs, go back to all those method for implementations, and see how you can apply these new features and greatly simplify your code. So put it on the checklist for your upgrade process to 11g. Well, I hope this was helpful to you. Even if you're not on 11g, it's good to have a heads up about what's coming. And in the future, happy PLSQL coding.